it later for people who aren't going to make it. All right. Question number 3 says, which triangle is congruent to triangle A? Okay, now they all look fairly similar, but what we want to do is we want to make sure that they are exactly the same. Okay, so one thing that we can do is notice the base of this triangle is 1, 2, 3, 4, 5 units. So we want to go through it. I'm going to each one to see if the flat part, now like D could be it, but it could just be rotated. C could be it. It's kind of in the same area. B could be it, but we want to check to make sure that all the segments are the exact same. So the base is 5. Here we go to B. I got 1, 2, 3, 4, 5, 6. The base of B is 6, so that can't be it. Okay. It could potentially be E. I'm going to go ahead and cross that out as we know it's not it. All right. Could potentially be E. My base is 1, 2, 3, 4, 5. All right. Could be E. D. All right. This one, D could be a rotation. E could be a reflection. So just because it's not oriented the same doesn't necessarily mean that it's not congruent. So D, I've got 1, 2, 3, 4, 5. Could be D. And C, we got 1, 2, 3, 4, 5. Could be C. All right. So next, all right, you see here how we get from this point to this point. I go left 1, up 4. So that is our direction, or that almost, it tells us the length of this segment, all right? So instead of talking about the diagonal, we can tell directly about the horizontal and the vertical distances. So if I go left 1, up 4. So from like right here, I'm going, if I go left 1, up 4, it doesn't match, right? Nor can I go from this one, left 1, up 4. Right? So C is out. Next, I'm going to go to E, right? We pick either one of those points. I go left 1, up 1, 2, 3, 4. It doesn't make it. E is out. So let's just make sure that D works. If I go up 1 to right 4, right? That matches. It's the same. We go 1 and then 4, 1 and 4. So let's just check to make sure that the next one works as well. We go up 1, 2, 3, 4 over 1, 2, 3, 4. For this one, we go 4 and 4. So what is A congruent to? It's congruent to D. Hold on a sec. Lucas, were you able to find the quiz review? Connor, were you guys able to find the quiz review? I'm just checking. I want to make sure you guys. It shows that you haven't opened it, so I just want to make sure that you guys were able to find it before we move on too much. So let's go ahead and, all right, so question number 4 says, true or false, the following triangles are congruent by the side angle side theorem. Basically, there are 4 different methods that we can use to show that something is congruent. Or sorry, actually, there's a 5th one. We can do side angle side, right? Do side side side. We can do angle side angle, angle angle side, right? One of them that you might get thrown off by is angle side side, right? And I'm not going to put the S in the S because you guys are high schoolers and you get together and you'll giggle and whatever, right? And I might get in trouble. So either way, I'm not going to write that one. But this one is no bueno, all right? That does not prove that triangles are congruent, okay? The 5th one, these 4, and then the 5th one is what we call the HL, right? This is the hypotenuse leg, and it only works for right triangles, okay? But the angle side is not an option. So if you see that one, okay, and it says if it's true, then it doesn't necessarily prove that it's congruent, okay? So question number 4, true or false, the following triangles are congruent by the side angle side, okay? So here I have this side congruent to this side. We have the angle congruent, and then we have the side. What we want to make sure of with side angle side is that the angle is in between the two sides. So here I've got my two sides right here, and the angle is in between them. I've got my two sides, the angle is in between them. So that's the case, then say it's true. Okay, question number 5. True or false? The following angles are congruent by the angle side angle. Okay, so I've got angle congruent to angle. We've got angle. All right, so now notice right here, if this says angle side angle, the side has to be between the two angles. So if we look at this, okay, the side is not in between them. All right, the side would have to be here instead of where it's located. So these are not congruent by the angle side angle. All right, if anything, this would be the angle side. But even at angle side, the triangle is not oriented correctly, right? Because you see how this side is next to this angle, right? The angle with the 1 tick mark. And on here, the side is next to the angle with the 2 tick marks. So this one we say it's false, right? They are not congruent. All right, true or false? The following triangles are congruent by the angle side angle. All right, this one, we have the angle side angle. Here we have angle side angle, okay? As long as the side is between the two angles and we have our congruent angles, then it's true, okay? These are congruent by the angle side angle. All right. Any questions so far? All right, we'll move on. Number 7, true or false? The following angles are congruent by the angle-angle theorem. Okay, is angle-angle one of our options? It's not one of our options, so it's not even a possibility. Okay, we'll actually look at this later on, but angle-angle is something we use for similarity. Okay, notice that these triangles are not the same size. Like this one right here, ABC, is much smaller than PQR. So they are not congruent. They might be similar, okay, but they're not congruent. We will talk about similarity next semester, right? How things can be similar, but not necessarily congruent. To be congruent, they have to have the same angle measurements, the same side lengths, okay? And these ones are not the same size. All right, question 8, true or false? The following triangles are congruent by the side theorem. Okay, first off, is side one of our options? Yes, side is an option for congruency. Okay, so now we want to make sure that we actually have 3 congruent sides. So I've got 3 tick marks, 3 tick marks, 2 tick marks, 2 tick marks, 1 tick mark, 1 mark. So yes, it is true. They are congruent by side. Okay, number 9, which of the following must be true in order for the following triangles to be congruent? Okay, so notice right here, right? This is a right triangle. The main one that we use for right triangles is the hypotenuse leg, okay? Now, in order for that to be true, it has to be a right triangle. We have to have a set of congruent legs, which we have. And we also have to have the hypotenuse. Now, the hypotenuse is the longest side, all right? And it has to be opposite of the 90 degree, okay? So this segment right here, AC, okay, that's line AC, has to be congruent to MN, right? In order hypotenuse leg, we have the BC is congruent to LN, that's our leg. We also need the hypotenuse. So AC is MN. All right, line AC must be congruent to line MN. All right. Question number 10. All right. This says, find the value of T that would make the following triangles congruent by the hypotenuse leg. Okay. So in order for the hypotenuse leg to be congruent, okay, or in order for these triangles to be congruent, the leg has to be congruent and the hypotenuse has to be congruent. So what that means is this expression right here has to equal this one. All right? So basically what we're going to do is we're going to take that expression, right? I'm going to take 5t plus 8 and set it equal to 7t, okay? So the question said, what value does t have to be in order for those triangles to be congruent? So those two expressions are equal because the legs are congruent. So now we just need to solve for t, okay? So here when we solve, I've got t's on either side of my equation. So I'm going to condense them. Right, so what I'm going to do is I'm going to subtract 5t on both sides. All right, so that way it moves that t over to the right. So 7t minus 5t is 2t. Okay. Now to finish solving for t, we're going to divide by 2. Those cancel. And t is equal to 4. Okay, so what does t have to be in order for them to be congruent? T has to be equal to 4. So don't type in t equals 4, just type in 4. Okay, just type in 4. All right. Questions so far? Okay, question number 11. Find the value of S that will make the following triangles congruent by the hypotenuse leg. All right? Same thing. The hypotenuse, they need to be congruent. Right? So we're going to take same thing. We're going to do the same thing that we just did. All right? And we're going to take those two expressions and I'm going to set them equal. Okay? What was it? 6s and 3s plus 33. We're going to set them equal. Now, notice I've got an s on either side of the equation. So to solve, I'm going to subtract 3s. It cancels. 3s is equal to 33. I'm going to continue to solve, so I divide by 3. And s is equal to 11. Right? So I'm just typing in 11, not s equals 11. All right, it won't count it right for you. We got 3 more questions and we'll be done. Okay. Then if you're finished and all caught up, you can go. And then if you still have some other things you need to get caught up on, then we can stick around and kind of work some of those out. All right. So given that triangle ACE is congruent to triangle BCD, match the corresponding parts of triangle ACE with triangle BCD. Number 11 was 11. Because we set those two parts equal to each other, subtracted the 3s, and then divided by 3. So we got 11 for it. Okay, so what I like to do on question number 12, right, is I like to do what we call a deconstruction, right? So I'm just going to put this off to the side so you can see what I'm drawing. So if we've got, basically, we can see that two triangles are overlapping. If these are congruent, right, there are also corresponding parts. So I'm going to draw triangle ACE. Okay, just like this. And I'm going to go ahead and label the tick mark. So we can see I've got a tick mark right here. This is A, this is C, and this is E, and we've got a tick mark here. Okay, then I'm going to go ahead and draw triangle BCD. But I'm not going to draw them overlapping. Okay, I'm going to draw them separate. So this is B, this is C, and this is D. This segment has a tick mark, this has a tick mark. Now, one other thing that we can say, right, is if you see here how they share angle C, we can see that angle C is congruent, right? And this right here is why we're able to say these triangles are congruent, because they're congruent by the angle side, angle side. Right? So now with that, because of that, we can say angle E is congruent to angle D, because those are the only angles left, right? And so here you can see that CE and CD, these are the shorter sides of the triangle. These have to be congruent. And then the long side over here, the long leg, these are going to be congruent. Right? So that's what we're looking for here. We're matching the corresponding parts. So angle A, right? Angle A corresponds to angle B. Okay. Angle C, right, corresponds to angle C. Angle E, let's look back here. Angle E corresponds to angle D. Right. We've got line AC. Line AC is right here. Okay, it corresponds to BC. E is this one right here, the one tick mark. It corresponds to BD. Right, and the last one, CE, corresponds to CD. All right, so it's helpful if we can deconstruct them. Right, pull them apart as two triangles so that way you can look at the pieces individually and compare them. It makes it a lot easier that way. All right. Go down to question number 13. 13 says, what is the angle measurement for angle D? All right. So what we have here, we have a special type of triangle, right? Not super special, just special, okay? This is an isosceles triangle. Okay, well, how do I know it's isosceles? It's isosceles because we have two congruent sides, okay? And it's kind of confusing here because it has these tick marks. So it makes you think that those are congruent, but they're not, okay? This is isosceles because these are congruent, right? So what we know about D and E is D is opposite of this side, E is opposite of this side. So we know that these angles are also congruent, okay? Now, how do I figure out angle D, okay? First off, we have to know that all three angles triangle add up to 180 degrees. So we know that this one is 50. So what I'm going to start off doing is I'm going to subtract 50 from 180, and I get 130. So what that means is angle D plus E has to equal 130 degrees. Well, because D and E are the same, if we can, in order to figure out what D and E are, all we have to do is divide it by 2. 130 divided by 2 is 65. So if we type that into the box, 65 is angle D, right? If it asks for angle E would be the same thing. It'd be 65. All right, last question. We'll go ahead and jump right into it. Okay, so the last one right here says, what is the value for X? Okay, well, once again on this one, cosine D equals 65. On this one, we have another isosceles triangle. Okay, it's isosceles because these are the same. So what we know about isosceles triangles, right, is that if two sides are the same, their opposite angles are the same. Those are what we call the base angles, right? So we know that this needs to be x plus 10. Okay, so we know we don't know any specific measurement for those angles. What we do know is we know an expression for each of them, right? So if I solve for x, we also know that all three of these add up to 180 degrees. So what I'm going to do is I'm going to take x plus 10, right? That's the first angle. I'm going to add it to x plus 10, right? The second angle. And then I'm going to add that to 3x, which is the third angle. If I add all three of those expressions together, I get 180, okay? Because that's how many degrees all three triangles need that to be. Okay, so from here, what do I do to solve? Okay, I'm going to combine like terms. X plus 3x is 5x. The 10 and 10 becomes 20, and that equals 180. Okay, so now what? So now we're going to subtract 20. 5x equals 160. We divide by 5. And x equals 32.